stream private. So you don't have to worry yourself. Should have to just give me her email address and then I'll just give it to her. Yes, it's private. Eh? All right, so let's go now. Now, so as we were saying, the word if in the hypothesis is like you're suggesting the cause. So it's like so why the plant grew taller was because water was added. You see it now? You see it now?
Yes, yes, sir.
So it's like you're giving a reason. Good. So we could also use the word reason in that as well. Could add the word reason to that list. Reason. Why something happened. So even when you're reading the textbook, if you have a textbook reading there, when you're making your notes in science, not just physics alone, but any science subject, look for if. Write your notes with the if and the then. So you put all the ifs, then you put the then. So technically, you're seeing the cause for something, you're seeing the condition of which something was under, and you're seeing the reason for it. Am I making sense there?
Yes, sir.
Good. So if you use this strategy, you will see that reading the information becomes more easier and more, you'll be able to understand it much better, but you have to utilize the approach. Now, where the then is concerned would have been the effect or the result. Good. What is actually observed. So this is where the observation is. Observed. What is actually observed. Good. So cause, if refers to cause, refers to condition, and refers to reason. Then the word then refers to the effect, the result, or observed. Remember those six words in the grouping under the word if and under the word then. All right? Got that?
Yes, sir.
All right. Good. So going forward, so with the first activity that we'll have to do then, you have to understand the purpose of a pendulum. Purpose of a pendulum. We want to see if we can watch a video. So you have an idea about a pendulum, simple pendulum. All right. Finish with this information?
Yes, sir.
All right. So the first activity was valid, right? Okay, good. All right, so seriously. All right. Um, let's try this side here. Not bad. I don't know if you're going to see it, but if you're going to see it, you can let me know. see my comments on the workbook. All right. What's the color for? Oh, that's the writing. Okay. All right. Let's look at a simple pendulum now. So let's remember now that you're going to be using the scientific approach. The scientific approach, not only when reading, but when you're going to do the lab itself. Let's see if we could try to find a simple little lab. All right, let's see.
Just sent you the email with the client
Looking at the
notes.
doc now, but I think it's an older version. Can you send an updated?
Monica, check.
Seen the video?
Yes, sir.
Okay.
Simple pendulum. A simple pendulum consists of a metal bob suspended by a light inextensible string from a fixed point. Let us now get familiar with the terms that we come across while learning a simple pendulum. The length of a simple pendulum is the distance from the point of suspension to the center of gravity of the bob. The resting position B of the pendulum is known as the mean position. One complete to and fro movement of a pendulum about its mean position is known as an oscillation or vibration.
Make note of that. Make note of that information there. One complete to and fro movement of a pendulum about its mean position is known as an oscillation or vibration. Make note of that. So look at a simple pendulum first. So in other words, place the string right there, goes here, then it goes here, and come back here. So B to A to C, and C to B is one oscillation. So you have to record the time after one oscillation. Is that clear?
Yes, sir.
Finish writing out the definition first?
Yes, sir. Finish now.
Okay. All right, let's continue.
The maximum displacement of the pendulum from its mean position is called amplitude. The time taken for
Hold on there.
of the pendulum from its mean position or vibration. The maximum displacement of the pendulum from its mean position is called amplitude.
So you have to make note of these terminologies, very important. So make note of that, please. So let's swing from B to A. that is amplitude. And from B to C, that is also amplitude. It's supposed to be equal. You get that now? Huh?
Finish writing that, sir.
All right, cool.
Amplitude. The time taken for one oscillation is known as the time period.
Make note of that. Very important information. So time taken for one oscillation is known as a time period. So I told you that as it finishes one oscillation, then you record the time. You stop the clock. You follow?
Yes, sir.
Mhm.
Finish writing that, sir.
All right.
To show that the time period of a pendulum varies with the length of the pendulum.
Now, if you are writing, going back to the if-then situation now. Which of these factors, what are the factors by the way, that will be observed in this sentence, or what we want to call it? What are the two factors right here, sir? What are the two factors? Can you identify the two factors?
Sir, time and length.
All right, good. The time period of the pendulum and the length of the pendulum. So those are the two factors. Now, question: which of the two that you just mentioned would have been the if and the other be the then? Which would have been the cause, which would have been the effect, which would have been the what other word did I use apart from cause? What was the other two words we use?
Condition and reason.
Condition and reason. So which one of them would have set the condition? Which are the two factors? Time period of the pendulum, length of the pendulum. Which one?
The length would be the if.
If. Good. Good. And then which one would be? So the other one would evidently be the effect. Would that be then?
Yes.
So in writing a hypothesis then no. So if you could construct a hypothesis using those two factors. Construct your own hypothesis using those two factors.
If and then, sir.
Yeah, man. Remember to say was all is if and then, right?
Sir, if a car is going over, if
No, man, there's no car in it.
oh crap, what was talking about?
You see no car in that picture? Have you ever seen a car in that picture?
So we have the pendulum and the
Yeah. If the,
pendulum.
let me say if I use a common sense now.
To show the time period
One little clue there, so I have to hide the clue, you know.
All right. So,
Uh-huh.
Sorry to show. Okay. So if the length of the pendulum is such and such, then the time period is such and such.
All right, all right, all right, all right. So what the such and such could be? If you're talking about length, what do you know about length? What is capable of happening to length and time?
You can repeat
Time
that?
normal, time normal do, what does time normally do? And length normally does. What time and length normally does?
The measure.
Yeah, but what them normally do?
Huh?
What they normally do?
Not sure, sir.
What time is it now?
It is now 2:35.
And what time we started?
It started 1 o'clock.
So what did length do? What did time do?
It measured how long.
No, 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 no. If we started at 1 o'clock, I know it's 2:35. Time is doing what?
It is continuing.
Yeah? Will the time stop at 2:34?
No,
Will
sir.
time stop at 2:34?
No, sir.
The time is always doing what?
It always continues. It's continuous.
So if it continues, but increase. That's what I'm trying to get out of you. Increase. The length increase too. And the time increase. So the such and such, you couldn't change the such and such with the word increase. Make sense?
Yes, sir. Makes sense.
Good. So reword it now. I'll put in the increase or decrease.
So if the length of the pendulum increases, then the time period increases.
Well, it doesn't necessarily have to, but that could be a hypothesis then.
Yes,
You
sir.
understand now? Because you are saying that if we increase the length of the pendulum, then the time period of the pendulum is also going to increase. That is what you are saying. That's what you are saying now. You follow?
Yes, sir. I follow.
You are saying that. But another person could say, if the length of the pendulum decreases, then the time period of the pendulum
Increases.
will reduce, vice versa. Yeah. So now it becomes now an investigation now. So we have a hypothesis. You see why it is important that first activity was important? It might look simple, but it is important. You see it?
Yes,
So
sir.
now you can think when you're reading, you're thinking in the scientific method way. You're not just carrying it out physically, but when you're reading or studying, because what I tell students about textbooks, textbooks is like a letter from the scientists. So they're just writing a letter to us about their observation, what they discovered through their, voyage, if you want to call it that, or experiments in the lab, whatever. Good. So bring the information alive by applying the scientific method of doing things in while even when you are reading. Make sense now?
Yes, sir.
Good. All right. So that means when you're doing the pendulum, then your first hypothesis would be, or I could write it, the length of the pendulum, if the length of the pendulum increases, then the time period of the pendulum will decrease. All right. All right. So let's see what he has. Let's continue. Listen to him now.
Tie the hook of a bob to one end of a twine. Clamp the other end firmly between the gap of a split cork that is fixed to the clamp of a retort stand as shown here. Measure the length L from the middle of the bob to the lower edge of the split cork. Mark on the table the mean position of the pendulum as a reference point. Pull the bob to one side and allow it to oscillate. Use a stop clock to record the time T taken to complete 10 oscillations. Now calculate the time taken for one oscillation. Repeat the experiment for different lengths. Plot a graph with t on x-axis and L on y-axis. The graph is a curve. This graph shows that
So this video basically is giving an idea. I will put it in the Schoology. So when you go back to it now, you'll be able to watch the video to remind you of what to do, right?
Yes, sir.
So I am looking forward to see your pendulum. So it's not a joke thing, you know. You have to make a pendulum. You understand?
Yes, sir.
Okay. Not a joke thing.
the time period varies with the length of the pendulum.
All right.
My job is to make college easier because students have a lot.
So that video will definitely be used for our activities. Oh, just as a reminder, I could actually send it to you now too. You bookmark it so you can go back to it.
Yes, sir.
All right, good. All right. So we're on the start. We're on the start. So if you want to increase on this performance here, improve the score. So you finished at 211. It told us what time you finished, isn't it? All right, so you can go to number 2. We'll finish at next 20 minutes there. You can go to number 2 now.
Okay, sir.
So you're at a total of 6 points. And this is a longer activity. Much longer activity this. Sure. You know what are the 7 fundamental quantities?
Yes, sir.
Okay. All right. I think it is type in answers already. Huh?
Yes, sir.
Um, what did you type first?
For my first answer, sir.
Mm-hmm.
Check. Um, it was length.
Length.
Yes, sir.
All right, hold on there. When the person designed this, I never reach right. So give me a second. Um, I'm gonna try to edit it. Hold on there.
Yes, sir.
Never edit it. You never do this thing here properly, so. As him have everything each up in a one little line, and that make no sense. You understand?
Yes, sir.
So the first one the type was length to say.
Yes, sir.
Common letters they use, right?
Um, the first, yes, sir. Common letters.
What was the second one you type?
Time.
Time.
Yes, sir.
The third one,
Amount of substance.
amount of substance.
Yes, sir.
Fourth one,
Electric current.
that's all like you read from your notebook. You read from your notebook, you read from your head.
Well, kind of from my head.
Okay. And the rest from your notebook.
Yeah.
All right, next next one. You must have wonder what we know that, right? All right. What's the E? What's the E?
Mass.
Mass. How about F?
Temperature. Then
Wait,
luminous intensity.
I have to write it in the order where you have it, you understand? So you actually get it right. What G be now?
Sir?
What G is? What you have is G?
Luminous intensity.
Humidity?
No, sir. Luminous intensity.
No, that's my mind is. All right. Spell that for me. L-U-M
Yeah, NOUS.
Lumi. N-U-O-U-S.
Yes, sir.
So it's a measurement of light.
Yes, sir.
Yeah. Remember a few things, no, really forget them much, you know.
Yes, sir.
Long time I not teach physics, but oh, a long time I not do physics. Physics and maths at the least. You understand?
Yes, sir.
At the least. I wouldn't know why I end up teaching physics too, no? So at least that. All right, you reach a number two already?
Yes, sir.
We have a number two.
For mass, I have. Wait, hold on. Classify the following quantities. It's fun. Oh no, I'm gonna read that.
Okay. Make sure common letters are used. There's a reason why I may ask. I want to make sure you use the common letters.
Okay, yes, sir.
And where you're writing more than one word, you just press the space bar one time.
Yes, sir.
All right. Maybe change something for Fremont. Because I'm sure now say you know get it on the computer. Maybe change it for you. This meters cube per cube. All right, so I'm gonna change that. When you reach number 5, A, B, C, D, E, F, G, H, I, write in alphabetical order. Got that?
Yes, sir.
When you reach number 8, use capital letters. Number 9, same thing, capital letters. All right, so let's start out.
All right, sir.
Okay, back to business now. Back to business. Right. Oh, yeah, your first time doing physics too.
No, sir.
You did it when?
Um, I have physics class in Calabar, so I do physics in
Yeah,
school.
no, no. I mean, not when I say first time. I mean it's your first year.
Oh yeah, first year, yes, sir.
Okay. Joey, you finish? You have a long line to go.
Almost, sir. Almost.
You almost or you have a long line? Which one?
Almost.
All right. Finish now? Joanne? Joanne,
Sir,
you finish?
no, I'm at last two, sir.
Okay, all right.
Sir, where do you say about number 8 and number 9, sir?
Number 8 and number 9.
Yes, sir.
The letters must be in number 8, number 9, alphabetical order. Sorry, not alphabetical order, capital letters, sorry, capital letters.
Okay, sir.
Mhm. All right, so next class, we discuss the results if it's not 100%. Okay, sir? You here?